Hi, my name is Tim Hodson, and I'm a product engineer with the software development group in Redlands, California. With me today is Chris Biscaglia, who also works on my team. Chris and I both work on the Survey Analyst extension to ArcGIS. We'd like to welcome you today to this live training seminar that introduces the Cadastral Editor. Cadastral Editor is a new part of the ArcGIS Survey Analyst extension. In today's seminar, we will discuss four main topics. First, we will cover some background information on land information systems. Then we'll present a new kind of data set called the Cadastral Fabric, how to add new land records to this data set, and finally, how to make use of the data to improve the coordinate positions represented by the Cadastral Fabric. Throughout the presentation, we'll be presenting examples on how to use the Cadastral Editor tools through software demonstrations, and we will also have review periods followed by a question and answer session, during which time Chris will be answering some of your questions. Today, in the interest of time, there will not be a Q&A session directly after the first topic, but you can start sending in your questions whenever you like. We'll have the Q&A session after the second, third, and fourth topics. Let's get started with our first topic, some background on land information systems. Well, what is a land information system? A land information system, or LIS for short, is any system with a focus on managing information about land ownership and taxation. The type of information managed includes, firstly, the legal description of the land in question. In other words, what is the shape and size of the land, and where is this land located geographically? There is a strong spatial component to the legal description. Secondly, the title defining who owns the land. Thirdly, information about easements. Easements are used when someone other than the owner has certain rights over parts of the land. A good example of easement use is for the placement and access to utilities. For example, an electric company owns the right to place power lines across property. Lastly, property values are also managed for the purposes of land taxation. All of this information under these four categories are referred to as cadastral land records. And cadastral land records are managed within a land information system. All of these elements are equally important in an LIS. The technology we describe today, however, has a focus on the first element, the legal description of land. We're focused in this presentation on the development of an accurate spatial framework to be used as a base on which to build these other elements of a land information system. Who maintains cadastral records? Well, here are some examples. I'll just run through these quickly. Large government organizations that have big cadastral authorities. Many cities manage a cadastral basemap that is used by other GIS departments within that city. Departments of transportation and utility companies. These last two usually focus on easements and rights of way. What do cadastral records look like? Here's one example. This is a subdivision plan describing the shape and size of 4 parcels of land. This is a legal description prepared by the surveyor. And you can see that it is very spatial in nature. It looks like a map. There are bearings and distances on this document. There are references to points. There are references to neighboring land. And of course, a reference to the parent property being subdivided. At this point, I want to introduce you to the Cadastral Editor and Cadastral Fabric. I will be moving straight into the second topic, but before I do that, we're going to take a quick peek at the Cadastral Fabric as it shows up in our catalog. As I mentioned before, please feel free to send in your questions at this time. Well, here we are in our catalog, and you can see here that I have a file geodatabase, inside of which we have a series of different data sets. These are feature data sets over here, and feature data sets contain feature classes. All of these feature classes in this feature data set have the same coordinate system and projection defined on the feature data set. This COGO source data All of this data and these feature classes were used to build my Cadastral fabric. The Cadastral fabric is located right here. If I open up the properties of my Cadastral fabric, we can take a look at the fabric classes. When a Cadastral fabric is created, a series of tables are represented for this Cadastral fabric. We have a control point table, we have a points table, lines table, parcels table, plans table, and so on. If I connect or click on my plans fabric class, you can see that I have a number of system attributes that are automatically created for me. So the Cadastral fabric classes have some system attributes. Just like standard feature classes, I can also enter additional attribute information to these classes. In this case, I'm going to add a source attribute, and I'm going to add it as a standard text field. I'm now going to do an identify on one of these parcels. So you can see here in my identify results that I have a parcel called 011, and it has associated with it a series of lines. The lines have bearing and distance information, from points and to points, and these from points and to points are also represented for this particular line. So I can click on one of these points and see its coordinates. Okay, I'm going to flip back to the slides and keep going. We'll delve into the Cadastral fabric a bit more in the next demo for the second topic. The Cadastral Editor is a new part of the Survey Analyst extension product. Here you see the existing technology that includes the Survey Editor for processing raw field observations. This technology has been available since ArcGIS 8.3. The Cadastral Editor is an addition to the Survey Analyst extension that was released with Service Pack 3 ArcGIS 9.2. The Cadastral Editor technology was built together with an Australian software development company called Geodata. When we started development of this technology, our goal was to build a simple system that would provide a new type of data set to store and manage land records in a geodatabase. We wanted to provide technology that enables our users to create and maintain an accurate spatial framework for a land information system. We wanted to be able to process survey-derived coordinates and cadastral land records in a productive editing environment. All this to ultimately allow us to improve and maintain the accuracy of boundary geometry for land parcels. We recognized that a dataset used as a base map for other GIS layers would require a means to also update these other GIS layers to keep them spatially in sync with the base map dataset. These are the 5 goals that we've worked towards with the development of the Cadastral Editor. The so-called base map dataset is called the Cadastral fabric. Only the Cadastral Editor can be used to edit this Cadastral fabric. Well, what is this Cadastral fabric? Firstly, you can think of it as a surface of connected parcels that have overlapping boundaries, but that share common points. You can also think of the Cadastral fabric as a network of connected parcel boundary lines. The legal description, bearings, and distances are stored on these lines. So you can think of the fabric as a surface of connected parcels in a dimensioned boundary network. The Cadastral fabric has an explicitly stored topology. For parcels 37 and 36, the fabric dataset stores 4 lines for each parcel. There are 2 overlapping lines where these parcels meet. The fabric only stores 2 points at the ends of the lines where these parcels meet. The points are shared by the parcels. This means that there may be multiple lines between the same 2 points. In other words, there are a lot of redundant lines. This is one form of redundancy. There are other forms, but for now it's enough to know that this redundancy is necessary in order to achieve spatial accuracy. More on this later. The common modern method for surveyors to define highly accurate positions on physical marks, such as iron pins and monuments that define the corners of parcels, is by using GPS. GPS can provide very accurate coordinates in a projected coordinate system. The cadastral fabric technology allows the data defined by this modern survey technique, that is accurate projected coordinates, to be integrated with the older land record data that is more historical in nature, that is the bearings and distances from the older cadastral records. Control points are not always directly tied to parcel corners. Often they are at a street intersection, for example. Connection lines allow you to tie parcel corners to these control points. This connection information is on the original record. It could be represented by a street width, for example. Next, I want to explain a little more about how the cadastral fabric data is stored. All the information is held in a set of tables. Each of these gray boxes here represent a table from the cadastral fabric. The first table I will describe is the plans table. Every legal document that represents one or more parcels can be stored as a single record in the plans table. That single record holds information about the date of the survey, the name of the surveyor, and so on. It stores information about the whole legal document. In this case, we have a single record representing the Crane's Roost subdivision. Each plan can represent one or more parcels. Here, parcel 28 has been added to the parcels table. You can see that it is referenced by the plans table. Parcels can only ever belong to a single plan. You can see here that we have an ID for this Crane's Roost plan of 1 in the plans table, and the plan ID is referencing this plan ID is referenced by this 1 that's also represented here in the plans table. So you can see that this parcel is represented by that plan. Parcel 27 is added to the same table and is also held in the Crane's Roost plan. Each parcel is defined by a set of recorded lines. The lines table will hold the lines from many parcels. You can see here that the lines that define parcel 27 have the parcel ID of that parcel. In this case, it's parcel ID 101. For each of these lines builds parcel 27 with the parcel ID of 101. Each line is also defined at each end by a point that is stored as a record in the points table. The latest computed point location is stored as attributes in the points table. Here you can see that the line 200 makes reference to the from and to points for the line. The control table stores control point coordinates. In order to be used in updating point coordinates, a control point needs to be linked to a point. In this case, you can see that the control point called CP1 is linked with a point 302 in the fabric. The coordinates of the point and the control may be different to start out with prior to any adjustments. For this reason, the control table also stores coordinate attributes. So here you can see in the points table, we have X, Y, and Z attributes for the points. And in the control table, we have X, Y, and Z coordinates for the control point, in this case, CP1. Finally, for the last table, I'm going to use a little graphic here. This is for the line points table. What are line points? This is best described with a picture. A parcel point becomes a line point when it sits on the boundary of an adjacent parcel, but does not split the boundary line. Since point 32 sits on top of the southern line for parcel 1550, it is assigned a line point record that gets added to the line point table and associated with parcel 1550. Let's go to this topic's software demonstration. Here you can see that I'm in ArcMap. The first thing you'll notice in my table of contents is that I have a series of layers. I have a group layer that represents my feature classes, utilities and easements. I also have down here a layer that represents some raster data that represents my scanned images for original cadastral records. And right here, you can see that we have the cadastral fabric layer. If I turn that off, everything disappears from the map, and I'm going to turn that on. That is my only layer that is visible right now. So everything that you see on the map is coming directly out of the cadastral fabric dataset. The cadastral fabric layer is actually a composite layer comprised of a number of different sublayers like control, line points, lines, and parcels. These are all, you saw all of these as fabric classes when I did the ArcCatalog little demo. What I'm going to do now is just do a quick identify on this parcel, which is parcel 001. When I expand it, I can get access to its lines, seeing them highlighted on the map when I click there. You'll notice right away that parcels have lines that define their boundaries, of course, but not only that, they also have lines that extend out from the parcel and connect to things like control points. These are connection lines. Another kind of line that you'll see are these radial lines that connect to the center point of the curve defined for this boundary. If I open my magnifier window, go over here and take a look in this location right here, you can see that I have a control point called CP5. And here you can see its coordinates. When I expand it, you can see that it is related back to the fabric point 2935. You can see that these 2 points have a connection defined within the database, within the cadastral fabric. I'm now going to identify this line right here. And in fact, you'll see that it is 2 lines. There are lines that overlap at this location. This line is the southern boundary of this parcel, highlighted. And this line is the northern boundary of this parcel being highlighted right now. You'll also notice that for this parcel over here, there is a line that's connecting down and touching the line of the southern parcel. And because of that, there's a line point defined right there at this red circle. So I'm going to click on that line point, highlight it, and take a look at the line point and see that it is a line point for this southern parcel. Something else that I'd like to show you. You'll notice here that we have all of these values showing up in red labels. These are values that are coming directly out of the cadastral fabric from the lines, from the records on these lines. This 97, for example, is connected directly, matches exactly the record from the original record from the survey record of the subdivision plan. Over here again, you can see that this 110 matches the 110 of the record. And again, this 8 in the record matches the 8 stored in the cadastral fabric. The point to be made here is that you really need to make sure, as best you can, that the original record data from the survey record matches what is in the database if you want to achieve spatial accuracy and tie it in with the control points. What I'd also like to show you, I'm going to turn on some feature classes here. Here I have some easements represented by green lines and some utility lines represented here in the blue. I'm going to use my magnifier window and go zoom right into this area, and you can see that this easement line the end of that easement line touches directly onto this cadastral fabric line. And we want to make sure that that spatial relationship remains intact as we move forward through this demonstration. In this section, we introduced the cadastral fabric. You can think of the fabric as a connected boundary network or as a surface of connected parcels. The primary goal of the fabric is to maintain the original cadastral record data and then also to use this data for improving the spatial accuracy of the cadastral layer. This cadastral fabric can then be used as an accurate base map for the whole organization. I'm going to hand over to Chris now, who'll take your questions. Chris?
Thanks, Tim. We have a question from Kevin, and he's at MacDill Air Force Base, and he asks, are dimensions auto-generated for parcel polylines or polygons? And to answer this question, yes, in the sense that if they don't have COGO attributes during the import, we actually just inverse those dimensions. Bruce from Juneau asks, what about surveyed curves? And we don't really talk about it too much during the demo or the presentation, but we do support curves. And we do, and we'll also think about coming out and salmon fishing. That was another one of your questions, maybe. John Ling from Arlington asks, how is the Cadastral Editor different from the standard editor in ArcGIS ArcView? And it's actually part of the Survey Analyst extension, and it was released with Service Pack 3. It's called the Cadastral Editor, and we do have a set of tools that edit parcels specific to land records, and we're going to talk about them more during the presentation. Bill from Nelsville asks, is this cadastral fabric new with the extension? And yes, it is, and it's part of Service Pack 3. That's when it was released. Adam from Seattle asks, can my cadastral data set reside in a Virgin geodatabase? And yes, it can, and we do support multi-user editing. Okay, and now we're back to Tim.
Thanks, Chris. In this next topic, we're going to talk about the different processes that we can use to enter new cadastral records into the cadastral fabric. Firstly, existing parcel data can be imported from any format that supports the ArcNode topology structure of the older 7x coverage format. We call data in this format cadastral fabric source data. Secondly, data can be added incrementally into the cadastral fabric from individual original cadastral record sources. These original record sources could be hard copy plans or scanned images. In these cases, the data can be entered manually using the bearings and distances for individual parcels as traverses, or otherwise building multiple parcels from a set of construction lines. The data could also come into the system as an electronic submission. An electronic submission could take the form of a CAD file, or it could be an XML format. There are different techniques for bringing this data of these various electronic forms into the cadastral fabric. Most cadastral records in North America, and also in other parts of the world like Australia, have historically been recorded and defined without any reference to coordinates. In this sense, each cadastral record is in its own local coordinate system. In the cadastral editing environment, you'll see that when you first enter data from the original record data, you do so in a local coordinate space. The user interface provides a blank map page and a blank spreadsheet grid into which you can enter the traverse data in this 0,0 coordinate space. You will see the parcel lines being drawn in this 0,0 coordinate space as the data is typed in. This environment is called unjoined coordinate space. We use the term unjoined as opposed to joined space, which refers to parcels in a projected coordinate system. In a minute or so, we'll talk about how parcels get from being unjoined to joined. But first, I'm going to talk about construction lines. In the cadastral editor, you're not limited to entering parcels one at a time as unjoined parcels. As you can see here, and as you'll see in the demo also, is that you can enter the parts of the parcels as construction lines. This helps, for example, when you need to take advantage of lines that are tangent to each other or collinear, and helps save time because you do not need to re-enter the same bearings over and over again. You can simply default to the bearing of your previous line. That's one example of how construction lines are useful. Just like the unjoined parcels, the construction lines are also in the local 0,0 coordinate space. Another very useful feature of the Cadastral Editor's construction line environment is that you can also use pre-existing parcels as a template for your construction line work. You can subdivide a parcel, a parent parcel, into child parcels. You can create construction points on top of lines and then digitize to link up the points to create the construction lines. The parent parcel remains intact and it continues to be stored in its original form in the Cadastral fabric. Once you've defined these construction lines, you can build new parcels from the construction lines. To get parcels from their local unjoined space into the coordinate system of the Cadastral fabric, you need to join them. The process of joining lets you define where the points of the unjoined parcels need to match the existing parcels in the joined parcel space. When you go through this process, you get a report of the joined residuals that include how well the data coming in matches the existing space that the parcel needs to fit into. The important thing to understand about joining is that it is first and foremost a process for defining connectivity in the boundary network. In other words, it is about enforcing the topology and making sure the right points are connected. This means that the shape of the high accuracy parcel may be temporarily, I should emphasize that, temporarily distorted to fit the existing low accuracy parcels. Remember, it's only the shape, not the record, that is changed here. And this is to emphasize that. You can note here that you're not changing the record value stored on the line table. In this example, even though the endpoints have had to be moved to make it fit into the existing cadastral fabric, the 100-foot record value has not been changed in the lines table, and the record for that line stays as the original value entered from the record source. Our goal is to now be able to use the connectivity defined by this accurate parcel along with its new record values on the lines to pull in the less accurate parcels to a more accurate position. This process on the right is called the least squares adjustment, and we'll describe that in more detail on the final fourth topic. But before we get there, I need to talk about Cadastral XML. With the release of the Cadastral Editor and Cadastral Fabric comes a new file format that can be used as a data exchange format. The file is an XML file, and it can be used to represent subparts or portions of the Cadastral fabric. In other words, pieces of the fabric can be clipped out and stored separately in this file or on your hard disk. These files might be used for backing up parts of the fabric, used for an electronic submission format, or used in support of managing an audit trail of cadastral work orders or cadastral jobs. The Cadastral Editor lets you easily export parcels into this new file. Of course, since it's a data exchange format, this file can then also be re-imported into the Cadastral fabric. These files can be thought of as portable work orders for little portions of the fabric. They can be considered cadastral jobs. Cadastral jobs are actually a concept that exists within the Cadastral Editor, and there is a jobs table that is part of the Cadastral fabric. I've not talked about these yet, but you will see them shortly in the demonstration. The demonstration is really the best place to discuss jobs. When bringing data into the fabric from a Cadastral XML file, it is referred to as appending data, since you are adding or appending parcel data into the pre-existing Cadastral fabric, which usually already has some data in it. Here you can see what the text in the file looks like. The structure of the XML file matches the data storage structure of the Cadastral fabric. In this demonstration, I'm going to introduce you to the various user interface components that allow you to work and navigate with the data and add new data into the Cadastral fabric. The first thing I'm going to do is add a new parcel into this area that will fit right at this location over here. Since we're editing in a geodatabase, the first thing we need to do is click on the editor and say, start editing on the standard editing toolbar. I'm now going to move this toolbar out of the view. And here we have the Cadastral Editor toolbar. I'm going to select the Cadastral Selection tool and select these two parcels and pull them out into a cadastral job to start work on them. The way I do that is to click Modify on the selection. And you'll notice two things happen. A few different things happen, actually. You get two new dialogues. One is the Parcel Explorer. This is the Parcel Explorer that you see right here. And you also see parcel details. In order to see the parcel details, we need to select a parcel. So I'm going to select parcel 29, and you can see the parcel properties in this property page. And you can also see the lines of this parcel over here. I can select parcels either in the map or in the Parcel Explorer. I'm going to select this second parcel here, and you can see that I also have information about the misclose on this parcel. See, in this case, it's about 1/100 of a foot. You'll also notice that these parcels are contained within a plan. Here you can see that we have a plan called 143/052. So that plan is named by its book and page number. That's in book 143, page 52. We're going to take a look at the properties of this plan. You can see that I have information. Again, I see the plan name here, and I can also add information as a description, such as being a portion, etc. The record format is also available. So this defines the record or the units and the manner in which the data is actually recorded on this plan itself. So I can see quadrant bearing, degrees, minutes, seconds, and units, and other various other settings, including for circular curves. In order to add a new parcel, I right-click on the plan and say New Parcel. You'll notice immediately that I have a parcel construction toolbar available to me, and I also have a local coordinate space, a blank white page where I can start, where I can see data coming into the local coordinate system, and then also an empty grid into which I can start entering record values. I'm going to enter a very simple, straightforward square parcel. You'll notice that I can use simply enter data using the numeric keypad, and I'm going to type in 45 degrees in the northeast quadrant, being -1, distance of 50, 45 in the southeast quadrant, 50. And as I go, you'll see that lines getting added into the map on the right. And now for my last line segment, I'm going to intentionally add a little bit of a misclose, 0, 1, and close it back off. And you'll see that I have a 0, 1 misclose represented here immediately. As I indicated previously, parcels don't only necessarily have to be defined by their boundary, perimeter boundary. They can also have lines that might connect out to a control point or connect across a street to an adjacent parcel. I'm now going to show you how you can add a new connection line. So here I'm going to click on this 0.3. It gets added to my grid. I'm going to add a connection line 25 feet out from that point. I'm going to change the type to connection. You can see it change color in the map. And now that I'm happy with these changes, I'm going to go and click Keep. This takes us back to the projected coordinate space, and we can see once again in our Parcel Explorer these two parcels that were originally there. But now we also have this new parcel, number 1. If I click on its properties, you can see all the information that I've typed in here, entered as the record. But you'll notice, of course, that since we're in a projected coordinate system, we do not see the parcel in this space yet because it's an unjoined parcel. We now need to go in and join this parcel into the fabric. In order to do that, I'm just going to zoom in a little bit. I'm going to right-click on this parcel and say Join. When I do that, the values for the lines of that parcel, or the lines, get added directly into the map, and I can into my existing map extent, and I can then take it and manipulate it and move it roughly into the position where I want it to go. I want this parcel to fit into this space. Now you'll notice right away that that does not seem to match I've intentionally exaggerated a scenario here that occurs with typical data of this nature, where adjacent surveys may be defined by different bases of bearing, and a record line that's intended to go between the same 2 points, or that represents a distance between the same 2 points in the field, may have different record values between two different surveys. So for the purposes of this demo, I've simply exaggerated that scenario. What I'm going to do is now join this parcel into the projected coordinate space. So I click on the point on the joining parcel and then click on the fabric point, and I'll do the same for this other point. And you'll see right away that I have a scale of 2 and a rotation of 326. Not only can I connect points to points, I can also connect this point to this line because I know this point belongs on that line. And this is going to create a line point. It's not going to split this line for this parcel. It's simply going to put a line point at that location. Line points are important because when we do a least squares adjustment and this parcel gets adjusted and these coordinates get adjusted, we want to make sure that this point stays on this line after these points have been adjusted. And you can see here the line pointer showing up as red. I'm now going to go and finish this work, finish the job, and post it back into the Cadastral fabric. Now you can see we're out of the Cadastral job and we're into the standard fabric view. And I'm going to identify this line right here. This is the line for the new parcel that we've added. And this is the line for the pre-existing parcel that was already there. Here's the record distance for each of these lines. You can see that we have 100 on this line and 50 on this line. And that's, of course, because I intentionally made this parcel, I gave it a high scale factor. But we know that this parcel is not very good and very accurate, and we don't want this parcel to participate in any kind of adjustment. We don't want the values. We don't want this 50 to be attempting to define the distance between these 2 points. So what we need to do is change the accuracy of that parcel. In order to do that, I'm going to go back to that same job. And the way that I do that is I open my job book, I find my job in the job book, I right-click and I say open. And this takes us back to the same view that we had before, right when I finished the job. So here I have my same job, but now I want to change the accuracy of this parcel 1. So I can go and open this parcel. Now notice when I open this parcel, I go back into its local coordinate representation of exactly the way that I entered it. So again, what you're seeing here is being defined and drawn directly from the record that's defined over here. But in this case, what I want to do is simply change the accuracy on this parcel to be the lowest value, which means that it won't participate in any adjustment. Once I've done that, I can click to finish that work in the Cadastral fabric, in the construction environment, and then finish this job and post that change back into the Cadastral fabric. The next thing I'm going to do is show you how we would do a parcel split. I'm going back into this area over here. I'm going to zoom in a little bit. And here's the area that we want to, this is the parcel we want to subdivide. And we're going to subdivide it into 5 different parcels. First thing I do is select the area around this parcel. Go back again and say modify. Extract that parcel, or extract those parcels into Cadastral fabric job. And this time I'm going to work directly from the map, right-click on the parcel and say New from Parent. I can get this context menu either from a selection in the map or from the Parcel Explorer. When I do a New from Parent, what I see is that same similar view as before, but with a few modifications. Here you can see rather than us having properties and lines in this parcel details view, we have construction, a construction set of lines that we can define construction lines for. The parent parcel is showing up in this local coordinate space as a template. We're not able to change or adjust or do anything with the actual record values, but we're going to use it as a template to create our new child parcels. First thing I'm going to do as a break line on this original parcel. I'm going to add record values of 68 that define construction points along that northern line, and do the same along the southern line. And now I'm going to start matching these construction points and generating construction lines, which you will see appear on your left right over here. And these are coming in directly from the inverse value between these two values. Now, we may not necessarily like the inverse value. In this particular case, this is very close to the actual record value. But if for some reason this did not match the record, we could go and change any of these numbers. If I, for example, go and change this to something different, 50, for example, first thing you'll notice is that that does not affect anything to do with the connectivity between those 2 points. And the other thing you'll notice is that this record automatically gets highlighted because the system is detecting that there's potentially something wrong with this number and it may be a mistake. I could still go ahead and accept this, but in this case, I know that it is in fact a mistake, so I'm going to change it back to the true record value of 106. And now what I can do is click the Build Parcels command. So I can build parcels from this. Once I do that, you can see that more familiar view of properties and lines for the parcel details. And then I can go and select each of these parcels that have been created from that parent parcel. Once I'm happy with this, I can finish this work in the construction environment, and you can see that child parcels are now sitting on top of that original parent parcel. I did not need to go through the process of joining again because we already had access, we already knew where those parcels belong based on the parent position. I'm now going to go ahead and finish this job and check those changes back into the database, back into the Cadastral fabric in the database. In this topic, we covered the concept of the unjoined space and the idea that you enter record data into a local coordinate environment. I introduced the construction line editing environment that provides a bit more flexibility in data entry, how to join parcels into the projected coordinate space. And also, I talked a little bit about the Cadastral XML format. I'll now turn it back over to Chris, who will again be answering some of your questions.
Thanks, Tim. Bill, MJ, and Richard have similar questions. They're asking about documentation and help, and it's all with the latest release in Service Pack 3. So you'll have online help as well as the help in ArcGIS. James asks, earlier it was stated that a parcel record in the fabric can only be related to one record in the plans table. Is there another table or relationship to the tax map? For instance, one-to-many, one parcel to many reference raster documents. And in the data model, we have those internal relationships, and those are made. But you can also have external relationships to say raster documents, for instance. So that's you kind of have that, yes. But in the actual data model itself, there is a parcel to one plan.
So to add to that, anything that you can do with existing feature classes is pretty much possible with fabric classes. So if you wanted to create a relationship with an external table, you could certainly do that from the fabric classes.
Thanks. Shauna from Spokane asks, can you build several parcels at once? And from Tim's last part of his demo, this question was probably before that happened, but yeah, you can. And Tim was showing how you can actually change record information as well if it didn't exactly match, if you were just digitizing lines from one point to another. June from Richmond asks, how do you use Cadastral Editor and Survey Editor together? And to answer that question, you can use certain elements of the survey data set with the Cadastral Editor. For instance, the control points. You can use those for your Cadastral fabric. And Rachel from Longmont asks, how can you import CAD data into the Cadastral fabric? And we do have a couple ways of doing it. The most common way that we found to do it is to add a DXF, or a CAD file to ArcMap, and actually borrow the geometry by just copying and then pasting that information into the construction grid. And that way, we're actually inversing the data that was on the CAD file, but depending on how accurate the CAD file is, it could be really close to record, and so you can actually modify it slightly to make it work. So that's one way of doing it. And we're going to go back to Tim.
Thanks, Chris. Now let's talk about our final topic, improving spatial accuracy. First of all, I'm going to talk about accuracy in measurement systems generally. In any measurement-based system, repeated observations provide system validation because they're used to double-check and triple-check the stored values one against the other. Multiple checks allow a system to identify mistakes that can then be removed by an operator. By removing mistakes, you can improve the overall accuracy of the whole system. Improving accuracy stems from repeated observations, and the term used in measurement systems for this is redundancy. Now, looking at the cadastral fabric, it can be considered a measurement system where the record bearings and distances, or cadastral boundary lines, are the observations. As we've seen, these cadastral boundary lines form a network that connect points together. In this case, for parcel 89, you see that with just a single parcel, we simply have 4 lines that connect 4 points. However, once we add these other 3 parcels, 19, 91, and 88, from potentially different record sources, you can see that the number of lines goes up to 16, but that we now only have 9 points. So this means that additional boundary lines define relatively fewer points. And this is really the essence of what we mean when we talk about redundancy. When we add the final ingredient, namely control points, we have enough information to update the position of all the points in this network. We're able to georeference parcel corners to the more accurate control point locations. The process used to do this is called the least squares adjustment. What does the least squares adjustment give us? Well, firstly, when all of the record measurements and control point coordinates are processed through this method, we get a best fit estimate of the coordinate locations. This means that if your data matches the original survey record and you have accurate and valid control points, that you can improve the coordinate locations of all the points, not only those tied to the control. The LSA process will also identify places where additional control points are needed. The least squares adjustment process can identify lines with values that do not fit well with the rest of the information. It's important to note that during this least squares adjustment process, the original record values are not changed. The control point coordinates are also not changed. What is changed are the coordinates of all the regular fabric points. The line work between these points are kept in sync with the changing positions of the points, but the values on the lines themselves remain unaltered. Here's a view of the user interface for the least squares adjustment report. These items highlighted in blue are the computed minus observed values. If you're familiar with the least squares terminology, you may also know these as residuals. These values are one way that the least squares report can indicate a problem in the record value or a mistake in the record value. In this case, you can see that we have a C minus O value of 1 foot. What this is telling us is that the coordinates computed between those 2 points, defined or computed from the least squares adjustment, are out of sync with the actual value on the record by a foot. Now, the reason that those coordinates were computed differently by that amount is that there was all this other information that allowed those coordinates to be computed, other than just this one particular record. So in a sense, you can think of this line on this particular parcel as having been outvoted by all the other record information around this parcel. A key element of the cadastral fabric is its function as a base map. In many organizations, we've seen a common pattern where the cadastral layer is maintained by a particular cadastral records department, but it is used as a read-only spatial reference frame by other departments. These other departments have a focus on other activities like maintaining services and infrastructure, but they use the cadastral layer as a spatial framework. An accurate cadastral base map can serve as a spatial control for the rest of the GIS. The adjustment vectors is a term that we use for the displacement between a point's coordinates before and after a least squares adjustment. These adjustment vectors can be used to adjust other GIS layers in order to maintain spatial relationships. The one thing to note here is that this is a different adjustment process and algorithm from the least squares. However, this GIS feature adjustment process cannot happen without the data generated through the least squares. In other words, the GIS feature adjustment uses the results from the LSA. And those results are, of course, these vectors. These vectors get used by the GIS feature adjustment. So I'm now going to go ahead and do the final demonstration for this fourth topic. I'm going to go to a bookmark area. I'm going to turn off my underlying imagery there. I'm going to select an area within the fabric that we'll then go ahead and adjust. Again, I go ahead and create a job, extracting all of these parcels out of the fabric and creating a cadastral fabric job. We don't need these dialogues, parcel details, and parcel explorer, so I'm going to shut those down so we can get a bit of a better view here. The first thing we want to do with the least squares adjustment is to take a look at the control points. So I'm going to open up the control point dialog. You can see here that we have a set of control points listed. For example, we have CP3 and we have its coordinates easting, northing represented down here. And we also have its point number, the point that it is associated with, the fabric point in the network. When I do a check fit, we can see how well the coordinates match. Each of the coordinates of the control points match with their underlying fabric points. And over here, you can see that we have about half a foot here of mismatch. This is useful information for the next step, which is to actually go ahead and do the least squares adjustment. So I'm going to close this dialog. I'm going to open up the adjust dialog and bring this down so you can take a look at this. I'm going to accept most of the defaults here, except for this particular one. Under the distances, I'm going to change the check tolerances to 3. This will not affect the actual coordinate locations that get computed. This check tolerances set of dialogues or options and values, they're simply a way to filter out the results of the report that I get back after I click the adjustment, after I click to go ahead and adjust. So in other words, any C-O values or residuals that are equal to or higher than these values will get reported in my least squares adjustment report. If any of the residuals are more than 3 times these values, then as a safety measure, the least squares adjustment will not, we will not be able to accept the results of the least squares adjustment. Now, plan structure constraints will actually allow me to make changes after the least squares adjustment has occurred, In particular, we want to be able to have line points match up and sync up with their lines. So I'm going to click that checkbox and go ahead and click OK to proceed with the least squares adjustment. I'm going to bring that report down so you can see it. Now, as you'll notice, the adjustment completed successfully based on those parameters that I defined originally. And you'll see that I have a bunch of other information here. I have information about the number of control points used, number of parcels, number of corners. And here you'll notice that we have number of bearings and distances at around 2,600, but the number of corners is 822. So here's a very good example of redundancy. We have this number of bearings and distances, 2,600 of each, defining roughly 800 corners. And the number of knowns is an indicator of the level of redundancy. We also see a maximum shift of about 5 feet here at 0.808. If we move further down in this report, we'll see that we have some suspect points and lines. So this is an indication of certain lines that we should probably look at for possible mistakes in the record values. Now, based on the settings that I defined, there was enough additional information, enough good information to maintain those coordinates within those check tolerances that I defined. So that's saying that so this is now, I'm allowed to accept this least squares adjustment. If the adjustment had failed, this accept button would not be enabled as a safety measure. So I'm now going to go ahead and accept this least squares adjustment, and then I'm going to go in and finish the job. So as that's processing, I'm going to talk a little bit about what it's doing. So everything that we extracted out of the cadastral fabric, all of the points were recorded as the starting point of before the least squares adjustment. Then now, as I'm finishing the job and posting it back to the cadastral fabric, the new positions of all of those points are also being recorded for each of the points. So because we have those 2 points before and after for every single point, we have an adjustment vector or a vector for every single one of the points in the database. So now if we go back, turn on our feature classes again, open our magnifier, and go take a look at what's happened. First thing we'll look at, we'll notice that whereas before our points and our control points were at different locations, after this least squares adjustment, they are at identical locations. So the points of the fabric have been moved into the positions of the coordinates of the control points. The control point coordinates have not been altered. If we go over and take a look at these utilities, you can now see this blue line used to match up with this edge of this fabric boundary. It no longer does so. And this was the one that we looked at before. You can see here that this green line representing the easement feature class is no longer in sync with the boundary of the cadastral fabric. We want to be able to go and correct this situation. So I'm now going to use the feature adjustment dialog and add in those feature classes. To make sure that we can adjust them. So I'm going to add them in and then also check them on to be adjusted. And then I'm going to go ahead and click the adjust button. Now what this adjustment is doing is it's taking all of those vectors and using them to adjust the positions of these two layers. So here you can see that my easement feature class is now back in sync with the cadastral fabric boundary. And over here you can see that this utility line is back in sync with the cadastral fabric boundary. If I don't like these results, this was all done as a single edit operation, so I can go ahead and undo those results if I do not agree with them, or I can go ahead and redo those if in fact they were correct. This is just also showing you the effect of this feature adjustment. In this topic, we saw that topologically connected parcels form a network of cadastral boundary lines. Using the information held on these lines, along with the control points, we can use a least squares adjustment process to get best fit estimates for coordinates in the fabric. And finally, that these resulting position changes can be applied to other layers to keep them spatially up to date with the Cadastral Fabric base map. I'll now let Chris answer a few more of your questions.
Just wanted to say that all the questions that are coming in are really good too. Marjorie from Las Vegas asks, are you able to use the plan information together with georeferencing? Or will using CAD data always copy paste? And what I meant by copy paste was to actually take that geometry and paste it into the construction grid. From there, you actually have to build the parcels like Tim did for that new from parent, and then you actually have to join it to the fabric. So that could be, that's similar to a georeferencing. So that's how you get CAD data in. Bill from Nellisville asks, I looked at our catalog, and in my personal geodatabase, I wanted to add a new cadastral fabric, but the cadastral fabric is grayed out. Why is this? And a couple of different, it could be a couple of different things. Number one, we require the Survey Analyst extension, so if you don't have that, you wouldn't be able to add a new cadastral fabric. Maybe the extension isn't enabled in the options. So that could be it. I'm sure that's what's going on. MJ from Bartow asks, are there tools to aid in converting existing coverages to the Cadastral Fabric format? And Tim mentioned it earlier in the presentation, but we can actually import COGO coverages directly into the fabric, and we do also have a data migration toolkit that will convert standard feature classes to the fabric source. Larry from Tavares asks, does Cadastral Editor allow you to create your own custom schema? And we do have our own schema for the actual Cadastral Fabric data set, but you can customize this in any way. Tim actually added an extended attribute to the data model. You can have external relationship classes, joins, all of that's still available because it does act just like a standard feature class would. Tom from St. Charles asks, what happens to the parent parcel after the split? And there's also another question here about tracking changes over time by Gary from Boise. And what we do is actually flag this parcel as historic. And so what you can do now is actually go to the properties of the fabric in ArcMap and choose to view the fabric at different points in time, so that all that information is retained in the database.
So the parent parcel is still kept in the database. It's still all there. All that information is there.
Okay, and Bill also has a question from Nellisville about, he asks, I was a little confused about why the distance was 50 feet when he created a parcel, but when he added it, it measured 100 feet. Did the distance change to 100 feet? The legal said 50, right? Well, what happened there was Tim was exaggerating scale and rotation when he joined it to the fabric. Now, anything that was entered in the construction environment or a new from parent environment is retained as record value, and that never changes. So Tim could distort that parcel as much as he wants when he joins it in, but that record information is always going to be preserved in the lines.
And the other thing to note there is, of course, that 50 was a gross exaggeration. I was showing how you could make, that could potentially have been an error, for example. And I intentionally set that parcel to be, to not participate in the least squares adjustment so that it wouldn't affect the positions of those points. But if I'd left it in the least squares adjustment, it would have been flagged as a problem, and I would have been able to go and find that and then correct it to the correct value.
Okay, and that's all for the questions.
Thanks, Chris. Before we sign off, I'd like to point out some additional resources available to you. We have a few courses coming up, and you can find those at the website shown here at training.esri.com. Early 2008, we will also have a course called Maintaining Land Records Using the Cadastral Editor. That'd be one to look out for. And we have some online resources. You can go to the Survey Analyst website shown here on your slide in front of you. And there's also desktop help. So that's all freely available. You don't necessarily have to have a license for this extension. To find it, you can simply go to that website and you'll see all the documentation for the software. And we have some white papers. So if, for example, you're interested in learning more about the least squares adjustment, what is the mathematical model, how does that all work, we do have a white paper on that. If you go under support, go to the knowledge base and find the white papers section, you'll be able to find that information. In a few weeks, the recording of the seminar will be available for free on the ESRI virtual campus. The resources listed on the slide and others will also be accessible from the recorded seminar. We hope you enjoyed this seminar today. On behalf of ESRI, I'd like to thank you all for attending.